we're given the we're given the graph of f here, and we're asked to find the x value where h has a relative maximum. Anytime we're trying to find a relative maxima or minima, what do we always want to find? We want to find the derivative, and so we want to find h prime. So we're just going to say h prime of x, which is the derivative, so the derivative of the integral from 0 to 3x minus 2 of f of t dt. Now, last lesson we learned that part 2 of the fundamental theorem of calculus tells us that if we have a derivative like this on an integral, those will cancel each other out in a way, they're inverses, and so we will input our function in and apply the chain rule. So we'll input our bounds, into our function, and we'll apply the chain rule. So this derivative, h prime of x, will end up being f of 3x minus 2 times the derivative of what's on the inside. In this case, it's just 3. So we're going to get 3 times f of 3x minus 2. That is h prime. And now we're trying to find a relative maximum or maximum in this case. So what do we need to do? When do we get maxima or minima? When our derivative is 0. So we're going to set this side equal to 0. Actually, let me use a different color so we can see that we're doing a different step here. The derivative is 0 because we're trying to find a maximum, and we need to find the x value that makes this true. I can divide both sides by 3, still get 0 on this side. So then we get f of 3x minus 2. When is f equal to 0 is the big question, and I can see that is happening right here at x equals 4. But that's when f equals 0. So our x doesn't equal 4. We're saying that this whole thing on the inside, I'll use blue now, should equal that 4. And so we can write that out. 3x minus 2 equals 4. Add 2 to both sides. 3x equals 6, and then x equals 2. And so we find that our function will have a relative maximum at x equals 2.